First, TACAN3D.com tutorial. In this second part, we will show how to access the application and the basic steps for using the controls in the TACAN 3D software. The first requirement to keep in mind is that access to internet is necessary to access this application. Once we have access to the internet, we enter the word TACAN3D.com. For security, before logging into the software, an access code will be requested, which is obtained by entering your name and email. To send this information, you must click on the Submit button, and to verify that the information was sent correctly, you will see confirmation on the top right part of the screen. After this step, we enter our email where we will find the code to access the software. We click on the link, and this will take us directly to the application where we must click on Submit and Enter to access the software. The application consists of 8 sequential points, which we must complete step by step. These steps correspond to our flight plan in anesthesia. Point 1 corresponds to the basic data of the patient. As an example, we will enter that we will administer anesthesia to John Smith, who weighs 75 kilograms, measures 168 centimeters, is a male, and is 45 years old. The main objective of this software is to design a flight plan before the patient enters the operating room, so it is important to know this data previously. Point 2 gives us the option of selecting what we will do in the induction. For this, we have 3 options: intubation, laryngeal mask, or sedation. Point 3 corresponds to the selection of the procedure to be performed and the suggested intensity of the surgical stimulus. For this step, we must click on the Select button. We are going to assume that our patient is going to undergo a cholecystectomy. We must then select the intensity of the surgical stimulus. 4 options are suggested in this step, which we have chosen based on data from some studies and are of great importance to have a starting point on the surface model. These points are only suggestions, since the anesthesiologist can change them according to the patient, the clinical condition, the adjuvant medications, or the individual experience. The first fundamental part of this point is to suggest a coordinate as a starting point to locate the patient in the model, which can later be modified at the discretion of the anesthesiologist. The second thing is that the TACAN 3D software has a database of the procedures that have been performed and in what spectrum of the surface model the anesthesiologist has navigated. This would allow to know the most precise areas in the future of where anesthesiologists often navigate for each type of surgery. For our example, Mr. Smith will be taken to a cholecystectomy, and our starting point in the model will be the range of abdominal surgeries, which we select and give an OK. Point 4 corresponds to the selection of the medication and how we will dilute them. In the first version of TACAN 3D, we have the most used medication, such as remifentanil and propofol. Based on this platform, a library of options of more medications can be created in future versions. We will dilute remifentanil in 250, and we will leave the propofol as it comes in its presentation of 10 milliliters. Point 5. At this point, the software, based on the information provided, develops a flight plan for the induction, taking the surface model into account. The starting point that the software suggests is to use a remifentanil concentration of 6.8 and a propofol concentration of 4 to have a PNR of 99. In how much time are we going to reach this point on the surface model? In 3 minutes. Let's pause a few minutes in this part to better understand the surface model. This is a surface model that results from the synergistic interaction of remifentanil and propofol. This model has 3 main variables. On the y-axis, the on-site concentrations of remifentanil are represented and correspond to the top controls on the right side. On the x-axis, the on-site concentrations of propofol are represented and correspond to the controls on the top left side. The z-axis is represented by the PNR, or probability of non-response, which is the mathematical result of the synergistic interaction between remifentanil and propofol. This axis of the PNR corresponds to the middle controls that are on the top part. The innovation of TACAN 3D is that the anesthesiologist can modify and control the PNR. Based on some studies and our experience, the suggested starting point to intubate a patient corresponds to concentrations of remifentanil ranging from 7 to 7.5 nanograms per milliliter, and at concentrations of propofol between 3 and 3.5 micrograms per milliliter. Keeping in mind the start time of the medications that we are administering, we suggest that the intubation PNR be achieved in 3 minutes. As we have reiterated, these are points of suggestion, and if the anesthesiologist decides to change them, he can do so. If the anesthesiologist, for example, decides that the intubation coordinates provided do not fit what he usually uses, he can change them easily. Let's assume that the anesthesiologist considers that he does not like those coordinates and decides to change them. Considering that to intubate this patient requires concentrations of 6 nanograms per milliliter of remifentanil and concentration of 3 micrograms per milliliter of propofol. The new thing about TACAN 3D is that the anesthesiologist can see from the spectrum in which area of the surface model he is intubating his patients. This information for TACAN 3D is very important because TACAN 3D can pick up this experience of the anesthesiologist and start to draw a map where we can see where the anesthesiologists are navigating to intubate the patients. TACAN 3D also allows us to select in how long we will achieve this goal of intubation. We can decide if we are going to intubate in 5 minutes, or we can decide that we will do it in 2 minutes or the time we consider prudent. Why do we recommend 3 minutes? Because the average time of KEO, or the start time of propofol, is 2.5 minutes. In addition, as a safety measure, we recommend avoiding the use of boluses or rapid infusions that lead to hemodynamic instability. Let's review. TACAN 3D suggests a PNR, which is the result of a coordinate with remifentanil and propofol perimeters. These perimeters can be modified by the anesthesiologist according to the preferences, according to whether he placed adjuvant drugs, according to the hemodynamic stability of the patient, and according to the clinical preferences he has had. For example, there are anesthesiologists who intubate with 5 nanograms per milliliter of remifentanil and 2 micrograms per milliliter of propofol. With these new coordinates, the anesthesiologist can visualize in what spectrum of the surface model they are intubating their patients. In conclusion, TACAN 3D manages reference points that can be easily modified by the anesthesiologist according to his experience and the patient's clinical conditions. Then we have the Z-axis that represents the PNR variable with its controls on the top middle. On the Y-axis, we have the presentation of remifentanil with its controls on the top right. On the X-axis, we have the presentation of the propofol with its controls on the top left. For Mr. Smith, we are going to decide to intubate with a concentration of 7 nanograms per milliliter of remifentanil and a concentration of 3 micrograms per milliliter in site effect. This gives us a PNR of 94, and we will decide to reach this PNR in 3 minutes. On the lower part of the model, we have the controls that give us the infusion rate information and the volume to infuse to reach the PNR of 94 in 3 minutes. In accordance with the recorded data in our flight plan, what does TACAN 3 recommend? First, that we must place the infusion of remifentanil at 368 milliliters for 3 minutes, which corresponds to passing a volume of 18.4 milliliters. Second, we must adjust an infusion of propofol at 126 milliliters per hour for 3 minutes, which corresponds to passing a volume of 6.3 milliliters. With these infusions, we will reach this point in 3 minutes, in the space corresponding to the PNR of 94 with coordinates of remifentanil of 7 and propofol of 3. Point 6. The software also gives us a PNR suggestion for maintenance. Let's remember, this is the remifentanil axis represented on the top right control. This is the axis of the propofol represented on the top left control. And this is the axis of the PNR represented on the top middle control. And that is the time which I can set and with which I want to achieve the suggested PNR in maintenance. For the flight plan in maintenance, the software gives a suggestion. For a cholecystectomy, the software suggests a navigation be started with PNR of 75. Which is achieved with 5 nanograms per milliliter of remifentanil and 3 micrograms per milliliter of propofol. This is a suggestion that encompasses the entire group of abdominal surgeries, and keeping in mind the diversity of abdominal surgeries and that surgical stimuli are perceived in variable ways. This suggested starting point could be modified according to the monitoring of the depth of hypnosis, the variables of pain, as well as the stability of the patient and the previous use of adjuvant medications or complementary anesthesia such as blockages. For abdominal surgery, the software suggests the selection of a starting point that will revolve around this spectrum. Usually for this group of surgeries, we will navigate in the green spectrum, which is the spectrum in which we move the most. For Mr. Smith, the software suggests a starting point corresponding to a PNR of 75, with concentrations of 5 nanograms per milliliter of remifentanil and 3 micrograms per milliliter of propofol. This point in the space suggested by TACAN 3D can be modified by the anesthesiologist according to the patient's clinical experience. TACAN 3D also allows to leave a fixed PNR and adjust the remifentanil or the propofol to continue in the same PNR. Let's pause on this concept. As we said, TACAN 3D suggests that for the maintenance of this anesthesia, we have a PNR of 75 as a starting point, with concentrations of remifentanil of 5 and propofol of 3. In the hypothetical case that the anesthesiologist would like to continue with the same PNR and change the concentration of remifentanil, then you should set the PNR and adjust the desired concentration in the remifentanil controls. TACAN 3D automatically executes the calculation and adjusts the concentration of propofol to remain at the desired PNR according to the programmed remifentanil modification. TACAN 3D establishes the starting points. These points are only reference points, which can then be modified according to the clinic and to the available monitor. On our patient, if the anesthesiologist considers using concentrations of 4 nanograms per milliliter of remifentanil and 2.5 micrograms per milliliter of propofol for a cholecystectomy, these coordinates can easily be adjusted. TACAN 3D is a software that allows the anesthesiologist to interact between the clinical area of the patient, the monitoring area, and the pharmacodynamic interaction of the medicines. TACAN 3D is a very flexible and user-friendly software where the anesthesiologist can adjust their own coordinates without exclusively committing to the recommendations given by the software. Continuing with the flight plan for Mr. Smith, we will assume that the anesthesiologist decided to change the coordinates and selected concentrations of remifentanil of 4 and propofol of 2.5. These concentrations result in a PNR of 30. Another option offered by the software is to be able to select the time after the intubation in which the PNR is to be reached and selected concentrations for maintenance. One fact that we must bear in mind is that we use higher PNR than maintenance for intubation. The question that we would ask is, what is the duration that we must select for the patient to pass from the intubation PNR to the maintenance PNR? TACAN 3D recommends a duration of 10 minutes to move from one PNR to another and thus avoid overshooting. However, if the anesthesiologist wants to achieve this goal in 5 minutes, it can be done. If you want to reach it in 15 minutes, you can do it. The duration to reach the point is deemed prudent at the discretion of the anesthesiologist. For Mr. Smith, let's assume that the anesthesiologist wants to reach the PNR maintenance in 5 minutes. Once my goals for the anesthesia are established in intubation and maintenance, we go and check the infusions established in TACAN 3D. In the remifentanil, this will be the infusion that must be placed to reach the established objective. And this would be the infusion that must be placed to reach the objective in the propofol axis. Let's observe how the remifentanil infusion will be 43.4 milliliter per hour, and the propofol will be 42 milliliter per hour. What would happen to the infusion if the target time were modified to 10 minutes? Let's see how the infusion automatically changes to 71.6 milliliters for remifentanil and 47 milliliters for propofol. Up to this moment, we have a flight plan for the anesthesia for Mr. Smith, both for induction and maintenance. Point 7. This step corresponds to the real mode, where we will navigate on the surface model. As we can see, the software shows us the PNR and the selected coordinates for intubation, which corresponds to remifentanil concentrations of 7 and propofol of 3. The top controls represent the objective we want to achieve. The controls that are on the sides of the model correspond to the start and stop controls. The update control, which must be pressed every time a change is made on the surface model. The simulation control is executed to advance or accelerate the patient's behavior in the surface model. The wake-up control is executed when the surgery is finished. Once a flight plan has been designed, we press the start control. What infusions does the software recommend achieving the proposed objectives? For the remifentanil, TACAN 3D determines that an infusion of 368 milliliters hour should be started, so that 18.4 milliliters will pass. And of propofol of 126 milliliters hour, 6.3 milliliters will pass. This is our goal on the surface model. As we can see, TACAN 3D is the first software that uses the concept of space as a function of time. Our goal is to reach the point in space in 3 minutes. TACAN 3D revolutionizes the concept of administering anesthesia when compared to TCI, Target Controlled Infusion Systems. The TCI system only provides information on the remifentanil and propofol concentration. Some systems that take the PNR into account only provide information on where the patient is located on the probability curves, but do not use the PNR as a main objective in the administration of these procedures. To better visualize the patient's movement in the model, let's increase the speed of simulation. We can observe on the lower controls how the infusions start. This displacement that is observed on the model is what is happening with the medications in our patients. TACAN 3D can show where the patient is navigating. As it can be seen, Mr. Smith has already reached the goal for intubation. After having reached this goal, the infusions are oriented to achieve the goal we proposed in the maintenance. TACAN 3D allows you to see where your patient has navigated. This innovative software is the first to control the PNR and incorporates the concept of space as a function of time. But let's go back to our patient, Mr. Smith. It's been 9 minutes of anesthesia, and the surgical stimulus has already begun. The bispectral index that was previously at 45 rose to 60. The systolic blood pressure, which was previously at 100 millimeters of mercury, is now at 140. The heart rate that was at 65 is now at 100. And the monitor of the nociception index started to rise. What should I do on this surface model? Increase the PNR? If you had it at 29, now you can increase it to 39. It can be increased to 40, increasing both the concentration of remifentanil and propofol. To execute this change, I must press the update button, and TACAN 3D automatically adjusts the infusions to reach this new point in space. Now let's put the software in real mode to better see the changes. This means at 1 times speed. Remember that TACAN 3D is controlling the concept of space as a function of time. The next question would be, in how much time do I want to arrive from this point that is my new objective? The variable of time is also at the discretion of the treating anesthesiologist. If the anesthesiologist is seeing slow and progressive changes in the monitoring, he could leave the time suggested by TACAN 3D, that is 10 minutes, but he could do it in 3 minutes, or the time he considers necessary. At minute 23 of the surgical procedure, Mr. Smith has an adequate systolic blood pressure of 100 millimeters of mercury. The heart rate is 65, and the proprioception indexes are adequate, but the bispectral index is now at 35. This could be interpreted as if Mr. Smith was in the appropriate anesthetic plane within a probability curve, but the only variable that departs from this perimeter is the bispectral index. Therefore, it would be ideal for Mr. Smith to remain on the same probability curve of no response, but with a less hypnotic component. To execute this action in TACAN 3D, first, I must set the PNR. Second, decrease the concentration of propofol to subtract the hypnotic component. With this action, we can observe how TACAN 3D automatically suggests that the concentration of remifentanil should be increased in order to sustain the same PNR. After adjusting the new objectives, I press the update button, and TACAN 3D shows the new infusions to reach the new objective in space. So far, we can see that TACAN 3D is a very versatile software, where it integrates 3 fundamental components. First, the experience of the anesthesiologist. Second, the monitoring of the depth of hypnosis and the monitoring of nociception. And third, the pharmacodynamic interaction of the opioid and the hypnotic. At this minute, Mr. Smith has the following monitoring data: bispectral index of 50, which we consider adequate, systolic blood pressure of 80 millimeters of mercury, heart rate of 50 beats per minute, and the nociception index is very low. This moment of the anesthesia can be interpreted that the patient is on a curve of very high non-response probability, but that the concentration of propofol is adequate. The most suitable navigation coordinate will be to lower the PNR, decreasing the target concentration of remifentanil and leaving the same concentration of propofol. Once the objective is established, we press Update to observe how the infusions are adjusted to achieve the new objective of PNR. TACAN 3D, a very versatile software where the anesthesiologist can locate a point in space as a function of time. This point in the space selected by the anesthesiologist will depend basically on the variables of anesthetic depth, nociception variables, such as a systolic blood pressure, heart rate, or nociception rates, and the experience of the anesthesiologist. With these variables, you can locate a point in the spectrum of the surface model, which is dynamic and allows finding an ideal plane in a more objective way. At this minute of surgery, Mr. Smith has the following monitoring data. Heart rate rises to 100 beats per minute, systolic blood pressure goes up 140, the nociception index goes up. The action to follow will be to raise the PNR and then press update. TACAN 3D will give the new infusions to reach the new objective. We can continue to place the situations in accordance with the patient's monitoring and move the PNR or the concentrations of remifentanil and propofol to adjust the objectives according to the patient's clinic. TACAN 3D is the first software that shows you in a 3D model where patients are navigating when remifentanil and propofol are administered. TACAN 3D is a software that allows visualizing the interaction synergy of remifentanil and propofol in a surface model that results in PNR. TACAN 3D should ideally be integrated or guided by anesthetic depth monitors, nociception index monitors, the patient's clinic, the experience of the anesthesiologist, and the use of adjuvants or complementary anesthetics such as blockages. With TACAN 3D, we have been able to identify that the average anesthesiologists navigate around this sector of the spectrum for cholecystectomy surgery, when in addition to remifentanil and propofol, they use dexmedetomidine infusions. We have been able to identify that anesthesiologists navigate this sector of the spectrum. When using doses of other opioids, they navigate around this spectrum. Continuing with Mr. Smith, the surgery is ending. The surgical wound begins to close. At this time, you can press Wake Up, where TACAN 3D recommends some coordinates to awaken the patient, as well as time. These coordinates can be modified by the anesthesiologist. TACAN 3D is a futuristic software since it can collect the navigation coordinates of the anesthesiologist for the different surgeries and map the spectrum sector where they are navigating. This would allow recommending more precise starting coordinates for students or anesthesiologists who wish to enter the total intravenous anesthesia.